All right, so last time we did a little review. We're going to start with a little review of some of the stuff we've done earlier in the semester again. This time we're going to start with for loops. And just to recall all the different things that you can kind of do in terms of program flow of control, right? Is you can write a program where you go all the way through and you run the same code over and over again. Okay, you can also write a program with the branching statement where it does this in some cases and goes around and does this in other cases. So it's a little more intelligent, right? Or can have some intelligence. It doesn't do the same thing over and over again. Then you can also write a program where you have loops, right? Which is what we're talking about, where you can process something over and over again, which is meaning you just run the same set of code, sometimes with slight changes. So if you wanted to do the same thing to a group of items in an array, you could run the same code on each of them. Something like, let's say I wanted to add 3 to them, or I wanted to check which neighbor was bigger, etc., etc. Okay, and then finally, is that the check which neighbor was bigger? Something like bubble sort is what I mean. And then you go on along your merry way. And then the final thing is, and then the other thing is, we could do functions which jump to another part of the functions or methods, right? They could be functions inside of a class, and they jump to another part of the program. It does a little processing, and it comes back, right? So all of these different flow of control methods are the basic ones we use in programming. Okay, so for loops. And for loops are really simple, but if you don't take notes on them, you won't understand them, and we use them all the time, right? So we're going to do 2 things. We're going to start with for loops, and then we're going to look at nested for loops, just so that people have an idea of what's going on. So I know you've probably all seen this before and probably understand it pretty well, but okay, something like that. And right, this could be anything. Anything that, or anything that evaluates to true or false. To true or F. I know you can't read this, but you can, I mean, you get the idea, right? So this is what we call the control variable. Okay, it can only, the control variable ends, so control variable drops out of scope when we leave the loop. So if we're like down here, the control variable drops out of scope when we leave the loop. Exit the loop. Okay, so far so good, right? And over here we have the condition, okay? And the condition, this evaluates a true or false. So it can be anything that evaluates a true or false. Here we have less than, but it can be, all of our expressions are fine. It could be I is not equal to, whatever evaluates the true or false, okay? So if you have a Boolean function, you could call your Boolean function in there. If you make a function that returns a Boolean, and that would be totally legit, okay? And here, what we're saying is, as long as this is true, we're going to continue through the loop, right? We loop as long as this is true, okay? Now, I equals I plus 1, it can be anything. I equals I divided by 3. All of those things are fair game, right? The point is here isn't it's that we're changing I. Okay, we're changing I. So we're changing I. Okay, so that we get closer to the condition. I'm sorry I'm writing so bad today, but I don't think it's going to get any better. Being false. All right? So it makes sense, right? If every time through the loop, this one gets closer to this being false, it'll eventually break out of the loop, right? And so that's how we know we've constructed the loop, or that's one of the sanity checks we do to ensure we've constructed a loop correctly. Otherwise, we might have an infinite loop, right? And sometimes we'll put like a print statement in here, and it'll flood the console, and we'll know, okay, we probably have an infinite loop going on, and try to figure that out. All right. And finally, what we have is how this thing actually starts. Okay, because students sometimes have issues with understanding that. Why don't I use red, because orange doesn't seem to be showing up today. So we run this, and that creates I in memory. Okay, this is literally I equals 0 in memory. Okay, and then so that creates the variable. We check this, so this happens first, this happens second. Okay, and if it evaluates to false, we flip out. So that's like an if branching statement. Okay, if it evaluates to false, we flip out. If it evaluates to true, then we go through. So let's say it evaluates to true because we set this up to probably evaluate to true right off the bat. And not necessarily though, right? It doesn't have to. Then what happens the second time around is we hit the end and we loop back and we check this. Okay, so that's kind of like the fourth thing that happens. This is kind of like the third thing that happens as code gets executed. Okay, and then the fifth thing that happens is we check the condition again. And if it's true, we keep on going through. If it's false, we don't. And then we update, we check, go through, update, check, go through, update, check, go through. Okay, so these two are executed the first time you go through the loop, and these two are executed every single other time you go through the loop. Okay, and if you kind of remember that, you kind of know I can't think of words today. The something of a for loop, the anatomy of a for loop. There we go. All right, I'll see you next video.